Welcome to Tangent Galvanometer session. In this session, we are going to discuss regarding how to use the tangent galvanometer to determine the strength of the current in the given circuit. Aim of the experiment: to measure the strength of the current in the given electric circuit using tangent galvanometer. The apparatus consists battery, plug key, rheostat, ammeter, commutator, tangent galvanometer and connecting wires.
A tangent galvanometer consists of a circular coil mounted vertically on a metal box. The circular coil is capable of rotation about a vertical axis. The coil of wire has terminals at the base of the instrument. They are 2, 50, 500. At the center of the coil, a box magnetometer compass box is mounted. It is also capable of rotation about a vertical axis. The base of the instrument is provided with 3 leveling screws. Now, the TG is made to be perfectly horizontal by means of a spirit level. Place the spirit level on the compass box so that it is parallel to the line joining any 2 leveling screws. The bubble in the spirit level should be in the center. The spirit level is turned 90 degrees in line with the third screw and is again adjusted so that the bubble is again at the center. Thus, the TG is made horizontal. When the current is not flowing in the circular coil, the magnetic needle in the compass box of the TG rests along the magnetic meridian. The plane of the circular coil is made parallel to the magnetic needle. Then, the compass box is also rotated to make the aluminium pointer read 00. So, these are the adjustments to be made before conducting the experiment.
Connections are made as per circuit diagram. The battery negative terminal is connected to the plug key and the other end of the plug key is connected to the rheostat. The second terminal of the rheostat is connected to the commutator terminal and the opposite terminal of the commutator connected to ammeter negative terminal. The positive terminal of the ammeter connected to the battery positive terminal. The remaining 2 terminals of the given commutator are connected to 50 turns of tangent galvanometer. In this way, we have to connect all the connections after the initial adjustments are over. After making the connections, we are going to switch on the battery. Then the current will flow in the circuit and the circular coil of tangent galvanometer. We have to adjust the rheostat for the required current. We can say that the current can be increased gradually when you observe in the ammeter. Here we can increase the current from 0 ampere to at most of 1 ampere. Here, when the initial rheostat adjustment is over for the required current, we have to observe the deflections of the aluminium pointer here from the top so that the aluminium pointer and its image in the mirror should coincide. We can take deflections theta 1 and theta 2. Now alter the two terminals of this commutator so that the current in the circular coil will be reversed. You now interview these two deflections again, and you can take theta 3 and theta 4 in the given magnetic compass. When all the deflections theta 1, theta 2, theta 3 and theta 4 are taken, we now enter them in the tabular form so that we can find the average value of theta. According to the tabular form, we have to find out the tan theta value. And now the reduction factor of this tangent galvanometer should be observed by considering the radius of the circular coil, that is capital K. Then I equal to K tan theta is the formula we are using to find out the strength of the current that is passing through the tangent galvanometer.
Now, let us see how to determine the K value. K is equal to 10 RH by 2 pi n. R is equal to radius of the coil. N is equal to 50. H is equal to 0.38 Oersted. Therefore, to determine the K value, we have to first find out the radius of the coil. For that, we find out the length of the coil using a thread. Therefore, L is equal to 2 pi R, that equal to 45 centimeters. Therefore, radius R is equal to 45 by 2 pi, that is equal to 7.165 centimeters.
In this way, we can conclude the tangent galvanometer experiment by verifying the observed values with the ammeter readings.